Good morning, everybody. My name is Jim Stevens. I am the FSR for Trane American Standard, Run True, and Ameristar in the Mountain region. Today, we're going to talk about equipment startup for the different kinds of equipment for gas furnaces, air handlers, outdoor units. Give you some little tips on what we do in our area to make the systems work correctly without having any callbacks, hopefully. We're going to start with gas furnaces and work our way through. Everything we're going to talk about today is in the install guides and general practices. So let's go ahead and get started. First thing we're going to talk about is gas furnaces. First thing we need to do when we set up a gas furnace is we need to test the gas pressure. So after we wire it up, we're going to test the gas pressure. We need to test the gas inlet pressure, and it needs to be between 5 inches to 10.5 inches water column for natural gas, and for LP between 11 to 13 inches. What we're going to do is we're going to set the manifold pressure for a single stage gas valve. We're going to use 3.5 inches for natural gas, and for LP, we're going to use 10 inches. If you have a two-stage gas valve, you're going to test and set the high fire first at 3.5 inches, and then we're going to set the low stage, first stage, at 1.7 inches for natural gas, and LP is going to be 10 inches and 7 inches for first stage on the LP gas. So always set second stage first, because the second stage sets the diaphragm, and the first stage, all it is a little orifice that we adjust down the gas pressure from the regulator down to whatever you want it set to at 1.7 or 7 inches. Okay, so make sure that you're testing the second stage first, and then first stage when you have a multi. This is the little kit you can get so that it fits over those new orifices that you're going to test from, the ports that have the real small Allen wrench inside. The older valves take a 1/4 inch, and it's actually an 1/8 inch Allen wrench. After we set up the gas valve, we're going to measure the temperature rise. We're going to measure the return temp close to the furnace. We're going to measure the supply temp about 4 feet away so that we don't have any radiant heat coming off of any of the metal components above the gas furnace. So again, measure the return real close to the furnace, measure the supply about 4 feet away. And basically, if your thermometer can't see the top of the furnace, you should be fine. So if you can only go a couple of feet, as long as you're around a corner where you're not going to have any radiant heat, that's good enough. Subtract the return from the supply temp. This is the temperature rise, or the delta T. So supply minus return equals the temperature rise. You want to look at the temperature rise on the furnace, which is on the nameplate, and it will say 30 to 60 or 35 to 65, whatever it is. And you want set your airflow to make your temperature rise halfway in between that temperature rise scale. So if it says 30 to 60, you probably want it about 45. So you're going to set your airflow to meet about 45 to 50. If you go too low, you can condense water inside of the furnace, too much water, and you'll have drain issues. If you set it too high, you'll have tripping limit issues when the furnace filter gets even a little bit dirty. So we want to make sure that we set it pretty much towards the center of the scale. In the service facts, there is a CFM chart. So what you can do is select your model number on the left-hand side of this chart. And then you're going to measure the temperature rise. And when you measure the temperature rise, say for the 80,000 BTUs, if you have 54-degree temperature rise, you have 1,400 CFMs going through that furnace. So that's a CFM chart by temperature rise for gas heat. That's pretty cool. It's in every service facts for every gas furnace that we make. Gas furnaces come set up from the factory at 350 CFMs per ton, because across the country, most people are putting in gas furnaces with an air conditioner. So it comes set up from the factory at the air conditioning CFMs per ton. If you're installing a heat pump, it has to be reset for 400 CFMs per ton, because all heat pumps have to have 400 CFMs per ton. So that's something that a lot of guys don't realize when they go to do their charging. You need to set the airflow to 400 CFMs per ton first, okay? And then do your charging, because if you do the charging first and then figure out that your airflow is not correct, you change your airflow to the correct flow, and then you have to redo the charge because your charge is not going to be correct because of the coil. The indoor coil airflow is going to be different. So to change the airflow, you can go into the system status. This is for an S9V2. You're going to go in and you're going to go down to, this is actually just the status menu. This is what tells you what everything's set at, okay? So you can go in and look at what everything's set at. To change it, you go further down and it says COP. It's compressor operation speed tap. That will be for cooling and heating. So your speed tap is going to be cooling 1.3, 1.1, 1.2. You're setting the second stage airflow. First stage airflow is 70% of second stage airflow. Okay. So you need to go in and set this when you set up the gas furnace. You have to tell it the outdoor tonnage. You have to tell it the outdoor unit type. 1:1, that's a single stage, single compressor. 2:1 is a two-stage single compressor. And a 2:2 is a two-stage two compressor. The difference between these two is the 2:2, it's 50% airflow and 100% airflow. Those are the older two-stage units with two compressors. The new two-stage equipment is a two compressor or a two-stage single compressor, and the airflows are 70% and 100%. So you can see how you can be way off on the airflow if you don't set this section correctly. Then we're going to set the cooling CFMs per ton, and this would be cooling CFM. So you can set it for 350 for AC, 400 for heat pump. Okay, if you don't have a 400 listed, get as close to 400 as you can. 390 is within 10%, so that's good. Okay, same thing for the heating CFM per ton. So you can set the cooling and the heating separately if you like. Typically on our variable speed equipment, we're going to set them all at 400. For our heat pumps, the airflow needs to be set the same for AC and heating because you've charged it to the 400 CFMs per ton. So set them both at the same speed. And that's all there is to set up a gas furnace. We need to set up the gas valve. We need to test the temperature rise, and we need to adjust the airflow for the heating if need be, and set the airflow for the outdoor unit if we have an air conditioner or a heat pump. Very simple installation, very simple checkouts. The air handlers get a little more in depth because each air handler sets the airflow a different way. All the gas furnaces basically set the airflow the same way. You get into the CDA, you set the airflow that way. On the older PSC motors, we would change the wiring on the blower, going to the blower for the speed taps. We don't do that anymore. Everything is on the board. You just push the taps, whichever tap you want, and that's how you set the airflow on the new boards. Okay, so it makes it very easy to do on the new equipment. All the new furnaces, all the S8s and the S9s, you can change the airflow on the fly. You don't have to cycle power or anything. The older equipment, if you were to change a dip switch or change the airflow, you needed to cycle the power before that change took effect. Okay, you don't have to do that with the new equipment. So for the air handlers, we need to look at the airflow performance table, and we need to look at our external static pressure to see where we're going to set our equipment. So this one's a GAM. This one has speed taps that are moved by moving the wire. Okay. Tap 1, tap 2, tap 3. This particular one is a GAM 4 AO36. It's got a PSC motor. It comes set up from the factory on tap number 2. So you're going to test your total external static pressure, and at 0.5 static, you're putting out 1150 CFM. So depending on the outdoor unit that you're setting this up with, that's how you're going to set your airflow. You set it to the outdoor unit, okay? This one's a TAM 7, TAM 8, TAM 9. Basically set up pretty close to the same way. You go into the configuration menu. You're going to go to the cooling CFM per ton, and you're going to select 400. It's already set at 400. So if you're installing it with a heat pump, leave it there. Heat CFMs per ton, same thing, 400 CFMs per ton. We're going to select the outdoor tonnage, tell it what tonnage the outdoor unit is, and it's going to set up your airflow for you. Okay. Cooling CFM, heat CFM, outdoor tonnage, and it'll do the calculation for you. For variable speed, again, we're going to set the outdoor unit tonnage. We're going to set the outdoor unit type, 1 to 1, 2 to 1, 2 to 2. Looks very similar to the furnace, doesn't it? We're going to set the cooling CFM per ton and the heating CFM per ton. Set both these at the same speed. This one's a TEM 6. This is a variable speed blower. This one has dip switches on the board. This is one of the ones that you're going to have to cycle power after you change the dip switches. I personally do not change dip switches with the power on. Okay. All kinds of weird stuff can happen when you're trying to change dip switches or move wires with the power on. You could arc something, the wire could slip out of your hand and slip over and touch the board, and boom, smoke the whole thing. And everybody knows, like Bob used to say, if you let the smoke out, you can't put it back. Okay. So be careful when you're setting things. Turn the power off when you're setting things. You have to cycle power anyway. So you're going to set the dip switch settings according to the CFMs per ton that you want. So this one, if you have a 2 ton, you want it to be 800 CFMs. You want 393 is pretty close to 400 CFMs per ton. It's within 10%. So you're going to set the dip switches as shown. Okay. And at the static pressures, you're going to get 773 CFMs out of that unit if you set it for off, on. Okay. So you need to know your static pressure again, right? 773 is within 10%. 735 is not. So you're going to smoke your compressor if your airflow is not correct. So make sure your airflow is correct before you do any charging. Your airflow has to be within 10% of the required airflow for the outdoor unit, or you'll smoke the compressor. Too high or too low. This one's a TEM 4. This one has speed taps, low, medium, high. This is another PFC motor. You're going to see the external static pressures on the left. For 0.5 static pressure at medium speed on 230 volts, you're going to get 1504 CFMs. Okay. I want you to look at the bottom of this chart and you see the number 5 in downflow applications. Airflow must not exceed 1600 CFM due to condensate blow off. Okay. So this unit, even though it's a 3-ton unit, you may be able to put on a 4-ton depending on matches. If you put a 4-ton on there, you can't run it in the downflow position at 1600 CFM. It'll blow off moisture. So basically what you have to do here is go to the bigger air handler, so that the bigger air handler is going to have a different airflow, must not exceed. Okay. It's probably going to be 1800. So you could actually set that air handler at 1600, meet your airflow, and not have blow off. Okay. So these are all the things that are in the product information in Gensco Customer, in Comfort Site, and DealerNet. All this information is right in there in the paperwork. Okay. So before you start selling stuff, make sure that you're looking at these things to make sure you're not going to exceed that 1600 CFM. I have this happen a lot. That's why I'm mentioning it. TAM-X, which is the brand new air handler. We use the app to set up the system. So you're going to use the app. You're going to, in 24 volt mode, you're going to tell it what the outdoor is. You're going to tell it, if it's an AC, if you're going to tell it it's a heat pump, you're going to tell it what size it is. You're going to tell it the CFMs per ton that you want. You're going to do all that in the app. Okay. In communication mode, it already knows all the airflows. It already knows the indoor unit and the outdoor unit, the tonnages, the airflow to set it at, because it knows that it's a heat pump or an AC. It's going to know everything. The only thing you need to set on the TAM-X is the lockouts, the accessories, and your floaty switch, things like that. So that one's really easy to do. So for the TAM-X, we're just going to go in. We're going to set the airflow. It basically sets it up itself in link mode. In 24 volt mode, we're going to go in and set it up just like any other piece of equipment. But we have to do it through the app. So if you don't have the app, the diagnostics app, get online and get the app for Link, and make sure that you take the Link class online. There's a little barcode for the app, and it goes through everything Link in the Link class online. It's in Gensco Customer also. Air conditioning. Setting up an air conditioning is very easy. We're going to set the airflow on the indoor unit, and then we're going to charge the outdoor unit by the subcooling listed on the nameplate. Okay. It's the only way to set up an AC. There are no heating charts or anything because it's AC only. So it has to be above 55 degrees outside to set up the charge. The only other way to do is weigh in the charge, come back in the summer, and test the subcooling. That's the only way to test an AC. Okay. You can put the refrigerant in. You can, you don't want to start it really if it's below 55, because you could have liquid in the compressor and damage the compressor by trying to start it when it's too cold outside. So I always wait in my charge. I would open my valves. I would turn over my disconnect so that somebody had to put it in. Okay. And that way it's not going to start before you come back out and start it up. Okay. It's not going to start when it's cold. We've got Nathan asking if you can use a charging blanket. You can. But you still need to come back after it gets up to 55 degrees and charge it in above 55 degrees outside to subcooling. Okay, that's the only way for charge verification that Trane accepts. Heat pumps. On a heat pump, when you're installing a heat pump, the first thing you're going to do is cut the J2 termination on the defrost termination temp. That's going to increase the defrost termination temp to about 70 degrees, and it's going to allow it to defrost all the way. You won't have banding on your defrost. Okay. Above 55 degrees outdoor temp, after we set the airflow on the indoor unit, right? We already talked about that. If it's above 55 degrees outdoor temp, we're going to charge by subcooling listed on the outdoor. Okay. And then if it's below 55 degrees, we're going to charge by the charging charts. And then we need to return in the summer and verify the charge by subcooling. Okay. Remember, the only way to verify the charge to make sure it's correct is by subcooling in air conditioning mode. Okay. We can charge the heat pump in heat pump mode, but it's not going to be as accurate as it is if we do it by subcooling in the summer. Okay. This is what the charging charts look like. We've got the charging curve. The bottom line is the outdoor temperature. We're going to take our outdoor temperature, say the outdoor temperature is 35. We're going to come straight up to this curved line, which is the indoor temperature. And then we're going to come straight across. And at 35 degrees, our suction should be approximately 90 PSI. For the head pressure, and this is first stage we're looking at right here. In first stage, we're going to go outdoor temp to 35. We're going to go indoor temp. Say the indoor temp is at 70 degrees. We go up to the chart, we go to the 70 degree line, and then we come straight across. And it's approximately 280. Okay, so that would be first stage, and we always charge in second stage. So if we're doing charge verification, we're going to go to the second stage chart. We're going to go to 35. We're going to come up to 70 degrees. We're going to come across. We should be right about 320. In second stage for the head pressure. Okay. If we are above the line, so if our real head pressure is 350, we're definitely above the line, right? We need to reduce refrigerant until it comes down to the line. So until we get down to the 320. If we're below the line, we're going to add refrigerant until we get up to the line. Okay. And then again, we have to come back in the summer and we are going to do the charge verification in the summer. Most contractors out there are selling a maintenance agreement or giving the first maintenance, actually just adding it to the job price, telling the homeowner, we're going to come back in 6 months and check your system in the next season. So if you sell it in the summer, you're going to come back in the winter and make sure everything's working on the heating side. And if you're selling it in the winter, you're going to come back and make sure that the AC is set up properly in the cooling side. So it's just an easy way to make sure that our systems get charged properly and not have to worry about charging somebody to go back or telling them we need to come back because we missed something or something like that. Yes, I do have the startup sheet for Gensco warranty, and that's one of the last slides in my slide deck. So give me just a minute and we'll go over that. So for variable speed systems, we're going to make sure that the indoor airflow is correct. 400 CFMs per ton. If it's a gas furnace, we need to do that. Even though it's a variable speed system, the mod furnaces come set up to run with air conditioning, because most times gas furnaces come set up for an AC, because that's what we use in most of the country. We're kind of oddball up here where we are putting in dual fuel systems quite often, and it's actually pretty rare in most of the country. So we have to change the airflow in the gas furnace to 400 CFMs per ton before we do anything with charging, okay? And then what we're going to do is we're going to go into turn the defrost termination to high on the outdoor CDA. We're going to also verify that the cooling and heating airflow is in comfort mode on the outdoor CDA. It's supposed to come defaulted at comfort mode. There's two different modes, comfort and efficiency. It needs to be in comfort, or it'll lower the fan speed too much when the system is in idle mode and it's just barely running in the lowest speed. It lowers the airflow too much and we get nuisance trips. And that's why we're asking you to do these things, okay? So defrost term to high to prevent banding. Verify the cooling and heating airflows in comfort mode on the CDA on the outdoor unit, so that we don't have any low airflow issues coming from the outdoor unit. Because remember, with variable speed, the outdoor unit controls the indoor fan, okay? On the stat, disable dehumidification to prevent nuisance trips due to low airflow. When charging, you must use charge mode to get the correct speed to match the charging charts. So that's a big one. I've got guys trying to turn it up to 100% on checkout mode, and that's not charge mode, okay? Charge mode is not truly 100%. It is a set speed set by the factory that they made the charging charts with, okay? And they don't tell us what that speed is because it's an algorithm that depends on the outdoor temperature, the indoor temperature, and then it uses that algorithm to set the speed of the compressor to match the chart, okay? So it's different each time. So if you look at it, you could go out to charge a unit today and it's 40 degrees outside, and you can come back in 2 weeks and it's 60 degrees inside. You're going to have a different compressor speed, and that's normal. Okay, so if you're looking at the compressor speed to try to do the charging chart, it's irrelevant. Okay, the computer inside of the drive selects the speed according to the charging charts that are published in the service facts. Okay, every one of these units has the charging charts in the back of the service facts. It's almost at the last page. So make sure that in heat pump mode, you're charging to the charging charts. In air conditioning mode, you're going to charge to the subcooling on the outdoor unit, just like we do with an AC, okay? Trade-in American Standard controls. Okay, for variable speed systems, the 24-volt systems wire the BK wire to the unit. So for a variable speed indoor blower and a 824 or 724 thermostat that has a BK wire, wire the BK and then cut the BK jumper on the indoor board. And what that's going to allow you to do is control the fan from the thermostat. So when you go to fan on, you go to options, and then when you hit the options, it's going to tell you 50%, 60%, 70%, whatever you want it. You can adjust it anywhere to 30 to 100% in 5% increments. So you can show the homeowner how to do that. And if they don't like the fan speed when fan on, they can turn it up and down and you don't have to go back. Okay, so cut the BK wire, or cut the BK jumper, wire the BK wire to the unit, control the thermostat from the thermostat control. On a S9V2 in a communicating outdoor, it's going to have a relay panel. You have to wire the BK wire from the unit to the relay panel, and you have to cut the J2 jumper, or the outdoor unit cannot, the BK jumper, I'm sorry, on the indoor unit, or the outdoor unit cannot control the fan speed. Okay. So make sure that you're setting it up correctly before you do any charging. If you don't set it up correctly, the outdoor unit can't control the indoor blower, and your charge is going to be off, and you're going to have to start over and do it all over again. Whenever you're setting up one of our controls, use the wizard. The first time you set up these controls, and until you've done a half a dozen of them, use the wizard every time. I use the wizard every time anyway, because you got to scroll through and look for the stuff. You might as well use the wizard, go all the way through it, and when you're done, you know you've hit everything. If you go into the technician setup, you could miss sections, okay? So if you just go through and do the wizard, it takes you through every section all the way through, okay? If you don't have a zone controls set up on the equipment, it's not going to show zoning section. These are smart controls. So if you don't have something wired to it, it's not going to show it, okay? Just so you know, if you're looking for zoning and you don't have the zone board wired yet, it's not going to allow it to show the zoning, okay? This is that startup form that James was asking for. It's the Gensco Tech form. It is in the tech section of Gensco Customer. It shows on the first page, it shows the gas furnace. It has a whole bunch of different readings for the gas furnace. It shows the model number and the equipment. It shows the homeowner's equipment and your company's information. So if for some reason you need somebody to come out and do a job site visit from Gensco, you need to fill out this form 100%, front and back, and then you need to call us from the job site so we can go over this form with you while you're on site and ask you, we may ask you to verify a couple of readings, you know, things like that. So those are the things that we need you to do for us, because you're the eyes and ears on the job site. You're the technician on site, so you can see, smell, feel everything that we can't from here. So we need as much information that you can get us so we can give you an educated answer, okay? Because at this point, we're honestly guessing, right? If we don't have all the information, if you only give me the refrigeration information and not the airflow, the information that I am telling you is a guess based on half of the information that we need to make a full diagnostic, okay? Because sometimes the TXV acts up because our airflow is incorrect. And the symptoms are just like a bad TXV, but it's the airflow that's incorrect that's given us false readings through the system. That's just an example of why we need the forms filled out. If you guys have any questions at all, go ahead and put them into the chat. I've got a few minutes here. We can answer some questions. James, it's in Gensco Customer. It's in Technician. It's in Technical Support. And then there's Forms. It'll be in there. It's called the Gensco Quick Form. Staging on a furnace on a 2-stage, you do the 2-stage, the second stage first, and then the first stage. So the easiest way to do that is I always use jumpers when I first start up my equipment. I jumper red to W1, and then as soon as the main blower come on, I jumper it to W2, and it brings on second stage right away. If you jumpers first and second stage, W1 and W2 at the same time, there's a 10-minute delay in between first and second stage. So jumper first stage, wait for the main blower to come on. After the fire and everything comes on, the main blower comes on, and then jumper at the second stage. And then it'll come on, set the second stage first, take the second stage jumper off, it'll go back down to first stage. And that's how we set up two-stage gas furnaces. The wizard is the setup wizard in the thermostats. When you very first start it up, it's going to say, do you want to use the wizard? You hit yes. And that's how it scrolls through. As you scroll through, it's going to hit everything in the thermostat that needs to be set up. So you can make your choices of what you want to set up. I believe this training is going to be on Gensco Customer. It usually takes a couple of weeks to get it on there, but you can listen to the training there. Yes, the two-stage gas furnace with a single-stage thermostat is a time delay. It's 10 minutes in between stages if you jumper W1 and W2 at the same time. And that is settable to 0, 10 minutes. You can go 5, 10, or 15 minutes. You set the time delay, it'll say interstage delay in the furnace board. When you're going through the tree, it'll say interstage delay, and it's default set at 10 minutes. Yes, if you don't have W1 and W2 jumpered, it'll never go to W2. So it does need to stay jumpered if you're using a single stage stat. If you're using a two-stage stat, you're just going to wire W1 and W2 separately. Most common setup problems is usually probably using thermostats that don't have a common wire going to them causes issues. Thermostats that utilize that don't have true relays in them. If they're using some kind of an electronic relay instead of a true mechanical relay built in, those are the ones that we have most of the problems with on setup. Because W1 and 2 are getting a signal at the same time. So it's going to wait 10 minutes before it brings on second stage. If it's a single stage stat, typically W1 is going to call first, and then W2 calls if it can't keep up by itself. So for the common setup problems, if you were to put a thermostat on one of our pieces of equipment, and it doesn't have a common, then what can happen is at the end of the cycle, when the flame goes off and it's supposed to do the, the 90-second or the 120-second cool down on the blower actually shuts off with the fire. So there's no cool down. That's one of the issues. One of the other issues is that sometimes it won't come on, or it'll be intermittent. So So that's why we need to use a thermostat with a common, okay? All right, James, I will send you one. Are you asking what is droop or what is the droop between first and second stage? So droop is the difference between first and second stage set points. So typically with our thermostats, if it doesn't maintain the temperature in the room, as the temperature drops, we use an algorithm. So it depends on how far it drops and how long it's dropped. There's not a set temperature. It's less than a degree though. So if it doesn't maintain, if it's set for 70, if it doesn't maintain 70 at about 69 and a half, it's going to start looking and saying, okay, I may need to ramp up depending on how long I've been away from set point. And then if you're set up as a W1 and W2, there's going to be a 10-minute inhibit. So as soon as it starts seeing that it's not keeping up, it's going to wait 10 minutes before it goes to second stage. And the reason for that is what happens if they're just bringing in groceries and they open the door, they walk past the, 2 or 3 people with groceries walk past the thermostat, and then they close the door, and 10 minutes later, it comes back up to temp. So that's why we have the 10-minute inhibit. And that's why it goes by how far away from set point and how long from set point. And it's measured at the thermostat. So yeah, James, I'll send you that form on email. Personally, I sold a new thermostat with every furnace because what happens if the old furnace thermostat goes bad? Who's going to pay for the new one? When you just charged them thousands of dollars for a new unit, I always put a new thermostat on every unit, every one. And the good thing about the new ones is you can make it as smart or as dumb as you want. You can turn off you can turn off all the scheduling. You can turn everything off. All you have to do, it could be up and down on your thermostat. That's it. So you don't have to do schedules. Arrow up and down, and it is real easy for homeowners, especially the older ones like me. I don't know what an IFM is. I would use an 824 stat for everything 24 volt. And then you can set it up however you want it. If you want scheduling, you can set it up for scheduling. If you don't want scheduling, you can disable the scheduling, and all it is an up and down thermostat. There's arrows with a set point and an indoor temperature. Very simple stat. Or you could set it up for 4 different schedules every day. So, as smart or as dumb as you want it.